As Mike said, I am Cris Guidi, and I've been leading the study team for Heavy Lift and Propulsion Technology. But I didn't do this alone, obviously. I had an incredible group of subject matter experts that joined me in laying out the point of departure plans, and that's what we're going to share with you today. But before I do that, Doug mentioned that we did some center assignments for the various technology areas, and for the Heavy Lift and Propulsion Technology area, we've got the Marshall Space Flight Center actually leading that effort for us. And specifically, I'd like to recognize Todd May. He is the center point of contact that'll actually be augmenting the study team and continuing on with the planning efforts for this area. So after this brief and throughout the duration of this workshop, if you've got any tough, ugly questions, Todd May at nasa.gov, and any compliments and kudos for the team, address those to me. Right, Todd? Ooh. We're missing some charts here. Okay, well, let me give a little bit of background since we don't have the right charts here. What I'm going to be sharing with you today is essentially the program content as well as some key points of the point of departure plan. I'm not going to talk the entire plan, I just want to hit some of the high-level efforts and share the program content. Are we going to get new charts? Okay, because I really need these other charts there. So can we take a couple minutes to go and get those charts? Because they really set the context of this technology area. Okay, we're going to just take a couple minutes here to bring up the full set of charts. Okay, I think we're there. I apologize. Okay, so here we are. Essentially, the outline is going to be pretty much the same. As I mentioned, I'm going to discuss the program content, the guidance, and some updates to that content that we were received. And then essentially, key elements of the point of departure areas, the needs, goals, the requirements development approach, as well as our system analysis and some of the near-term activities that we're going to be doing in the heavy lift and propulsion technology area. Okay, give a little bit of context. There have been several reports that have been released recently that really provide the context and the framework for the heavy lift and propulsion technology area. And interestingly enough, most of the reports are actually identifying that there is a need for a heavy lift launch vehicle for human exploration, as well as investment in the associated technologies for that vehicle. Most visibly is the recent Augustine report that was released late last year. That overall theme of that report essentially recommended to NASA that we have to go off and find an affordable and sustainable approach to human exploration. And throughout the report, they provided a number of options, each one of them containing a heavy lift launch vehicle. So that was key. And in that report, they also implied that if there is a heavy lift launch vehicle, there will also be other uses, not just for human exploration, but also for science missions as well as national security. But the one key thing in that report that really sets the tone for this entire technology area is that they observe that NASA tends to aim frequently towards the design for performance at the sacrifice of cost and reliability and operational efficiency. So again, I want to highlight that key quote because that will definitely be the tone throughout this entire program. We're actually shifting the approach of how NASA is approaching launch vehicle development and propulsion system development more towards an affordable approach rather than focusing solely on performance. And then In late December, the Office of Science, Technology, and Policy, they recently submitted their report. They did a study on the industrial base, the health of the liquid propulsion industrial base, and they too found some challenges, significant challenges, as a matter of fact, pertaining to liquid propulsion. And the challenge there is, since there's such a low demand on launches, there's a low demand on propulsion systems, which then means it doesn't make sense for private industry to invest in technologies in that area. To compound the problem, the government is not investing in that area as well. So again, there's a significant challenge in maintaining the critical skills we need in the propulsion development area without some kind of technology development program, which, again, these two reports really set the framework and the basis for the heavy lift and propulsion technology area. And we plan on addressing a lot of these key concerns within this program. So now the program content. Something that dawned on me as Doug was presenting, I didn't realize this until he said it, that with the FY2011 budget, the money that we have been allocated for heavy lift and propulsion technology, we will actually be investing more in heavy lift than if we continued on with the Constellation program, which is significant. That's a key element that I think we all need to keep in mind. But we've been given approximately $3 billion over the FY2011, FY2015 timeline to focus on three key areas of the heavy lift and propulsion technology area. First one is R&D in the first stage launch propulsion. And our current plans are to develop a large hydrocarbon engine capable of producing over 1 million pounds of thrust or greater, but with the focus of affordability, reliability, all the ilities. And our intent is to partner with DoD at minimum and hopefully involve commercial in this development effort so that we can evolve towards a national engine where we all can use the same engine for multiple vehicles, with the goal of a fully operational engine in 2020. The second technology area, or development area within heavy lift, is in-space engine demonstration. And right now the trade space is pretty open. Our focus is going to be on LOX methane or LOX hydrogen, and maybe both, depending on the budget available. But our system analysis of the overall launch vehicle will influence which approach we actually put as priority in the in-space engine demonstration. And then finally, the third area is the foundational propulsion research. I don't like the word foundational because there's a connotation that it's very low TRL or game-changing technologies. But essentially what that technology area is, we'll be focusing on technologies that'll help the engine development efforts above it that are directly applied to those engines. So it's more of a technology pull rather than a technology push from the technology area. So it'll be directly applicable to the first stage or core stage engine and the in-space engine as well. And the key areas that we're going to be focusing on there, new propellants, advanced propulsion materials, manufacturing techniques, again, with the overall goal of reducing cost of the propulsion systems and the overall launch vehicle development as well. And then you see the other areas, combustion processes, storage and control, and engine health management. We're not going to be limited to these areas. These are just examples of key areas. And our studies, as well as engagement with the community, will help flesh out what technologies we actually go and pursue. So on April 15th, President Obama went down to Kennedy Space Center and had his space summit. And in that announcement, he did reemphasize certain things: his 100% commitment to the mission of NASA and its future mission, also the ramping up of the robotic missions and to the solar system, commercial crew service to LEO. But the one key element that actually was a slight shift or clarification was the President actually gave us a milestone for heavy lift and propulsion technology. And what he, like many of the studies that we've seen published recently, he recognized the need for a heavy lift launch vehicle to carry humans beyond low Earth orbit, and he gave us a milestone of selecting a design for this vehicle by 2015. And as Doug says, we're still working out the details as to what truly is that milestone. But that was very positive for us because we now have an endpoint for how to feed these engine development efforts and the technology development efforts for an endpoint, again, for humans beyond low Earth orbit. So one of the first things as a study team we did was we actually defined needs and goals to kind of frame the overall, again, tone of the program and where we're going to go. This is a point of departure. However, some of these items will be considered stone tablets, I would say, but maybe the flavor of it a little bit. But I'm not going to go over every single one of them, but the key one, which is right at the top, is affordability. Again, this sets the tone for the entire program. Our focus will be on developing affordable propulsion systems so that we can enable a sustainable human exploration mission. And when affordability also includes all the other abilities, operability, reliability, make sure that your system is robust. So that is really going to be our key figure of merit for this entire program. The second goal is the capability to perform multiple missions. And the intent here is once again is to develop a system that can be used for multiple purposes, multiple end users. And the concept there is so that we spread the industrial base or the fixed cost across the customers so that we have more affordable systems, but also just to make sure that we can provide a robust industry to actually provide these systems for us. And obviously, a key goal is risk reduction. We're going to have a robust technology development effort, transform the industrial base. This goes back to the OSTP report that was released in December. We feel that a key tenet of this program needs to make sure and build up a robust liquid propulsion industry base so that we can maintain the national capability and gain world supremacy in that area. The next goal, time frame, obviously you've got to be timely with your products. We've got a goal of providing an operational engine by 2020. That doesn't mean that we're not going to pursue an earlier delivery of the engine, but right now that's our goal. And the current point of departure for the in-space engine, our baseline right now is LOX methane, and to do a demonstration, a flight demonstration in partnership with the flagship technology demonstration program by 2015. But again, that may change based on the system analysis that we're going to perform in the next couple of months, which may influence what type fuel we use as this demonstration. So it may be a LOX hydrogen version instead of a LOX methane. And then our goal obviously is to develop an upper stage engine by 2020 and to finalize the launch vehicle design so that we can support a human exploration mission to the near Earth orbit by 2025, as President Obama stated in his speech at the Space Symposium. Then the next goal, partnership. Again, we're going to have to do this together. As I mentioned, DoD and NASA will definitely be partnering in this effort. However, we'd also like to include commercial in this development arena, again, so that we have a national engine for multiple customers. And not only industry and DoD, but we also have to partner with our academia partners as well. We're going to be looking at academia to solve some of the technology challenges that we're going to be faced with during the development of these engines and the launch vehicle. So it's definitely going to be a multi-input problem here that we all need to gang together to actually solve this problem. So again, I just want to mention that these are the point of departure needs and goals that the team put together, but as we continue on and we engage you all, these may slightly morph, but the key goals and what I call the figure of merit or the hot buttons that we are really going to set the tone for this program are affordability and also propulsion systems for multiple users. So our requirements development approach, again, with the goal of multiple users, we have to somehow figure out, well, how do we scratch everybody's itch? So our approach here is to engage with the stakeholders, individuals or entities that have propulsion needs or launch vehicle needs, collect that data, and this is a notional graph that's actually showing thrust as a engine characteristic, for example. We're going to collect that data from the community and do some system analysis to figure out, is there a sweet spot where we can actually enable a national engine for everybody's use, and we need to make sure that it doesn't decrement the performance of the mission. It needs to satisfy the mission, obviously. But again, we're going to do this initial system analysis effort to understand if there is that sweet spot. And more long-term, the plan of this program is to go off and create a stakeholder advisory group. And the intent here is to have every stakeholder that wants to be involved in this effort to actually follow on with the NASA development of the engine and the propulsion systems to make sure that their needs are truly being satisfied. Okay, so the sweet spot. This is really the key thing right now. We promised to see if we can develop a sweet spot, but we had to test a little bit of, we had to do a feasibility check to see if we can actually do this. So NASA just recently initiated an in-house study. Actually, we had a kickoff meeting on May 11th. It's being led by Gary Lyles out of Marshall, but it also involves the several Air Force participants to collect data and do a quick look to see if we can actually develop a sweet spot and see the impact of having a common engine for multiple users to make sure that we can actually accomplish the missions. Like I mentioned, that we've got participation from Air Force right now. The completion date right now is the 21st of June, and again, it's just a feasibility. It's not going to lock us down to a particular thrust level or anything. It's just can we even achieve a common engine between the two entities? Our plan is down the road, as you'll see in a couple charts, is to engage the broader community. But right now, we wanted to do a quick in-house study to actually see if this is actually capable. So, the near-term activities for heavy lift and propulsion technology. As many of you know, we released an RFI on May 4th, and we received responses last Friday at midnight, and I have to tell you, we had an incredible response, 43 total RFIs, and I want to thank you all for actually taking the time and effort. We've got some incredible data coming in those RFIs. But essentially, that was the first attempt to engage the broader community to help influence where we're going to go in this heavy lift and propulsion technology program area. That information from these RFIs will also influence the follow-on activities. For example, the broad area or agency announcement that we just released last Wednesday, the 19th. It's the draft. What we're seeking there is, again, that's the second opportunity, and this is more for study efforts for industry to engage with us, NASA and Air Force, to help us develop some system concepts, again, to really formalize, is there a sweet spot for a national engine and a propulsion system? But again, this RFI is going to actually feed into the broad agency announcement and as well as your comments. We're looking in this BAA about a 6-month effort. We've got a targeted amount of contracts that we want to award, but we don't want to commit to that right now. But we feel like this is really going to be the first time that we're actually going to engage you all to start the actual development and planning of this effort. So a little more detail on the BAA. Essentially, as I mentioned, the BAA is actually going to extend and continue on a heavy lift launch vehicle in-house study that was performed last year by some NASA civil servants. We're going to focus on a broad set of launch vehicles, not just RP like what you saw in the initial program content. We're going to look at LOX hydrogen systems, we're going to look at LOX RP systems, we're going to look at in-space architectures, multiple propellant combinations. So this is about as broad as we can get, because what we want to do is we want to perform an in-depth study to figure out what is the most affordable approach to propulsion development as well as launch vehicle development. And again, the focus is affordability, operability, reliability, and we also want to understand, we want to have industry inputs and ideas on how this development will support multiple users. Again, that's another one of our key FOMs. The technical objective of the BAA is to determine the technology and research development for this program area, and as well as identify different concepts. So I'd like for you all to take this opportunity. We're going to have one-on-one meetings tomorrow to actually discuss further discussions on the RFI if you submitted one, or clarify any questions on the draft BAA, but also accept comments and recommendations on how to improve the BAA, and then eventually we'll go off and release a final with your comments. So, in closing, I feel like we've got a robust technology development effort in heavy lift propulsion. It also gives us the opportunity to start working towards the development of a launch vehicle, and we're engaging the community here to help us with this overall effort, and we are definitely looking forward to this, and we need your help. So with that, any questions? No questions? Oh, I had to encourage it.
I just have to ask something to make you feel better. You're looking awkward up there.
Todd, this one's yours.
Max Vozoff from SpaceX. A number of times through the presentation and on the slides as well, you've referred to a national engine,
Yes.
always in the singular. Is it just assumed that there's not enough money to sustain more than one, perhaps cross-compatible propulsion system?
We don't know that yet. Again, what Todd's team's going to go off and do is actually start working the budget aspect of this program. But right now, we're looking to see to develop one engine right now, but that's not to say that there won't be another one. The only concern is we need to make sure that we can actually sustain an industry base with multiple providers. But the key tenet of this program is, again, to spread the fixed base across multiple customers and provide a robust development of one engine where the production rates are high enough.
Mark Robinson, ASU. So I've got an easy question and maybe a nebulous question. The first one is just to help me and other people who maybe aren't engineers put into context the development of this engine. How does this compare to the space shuttle main engine? You know, is it twice as powerful, twice as efficient, so on and so forth? And the other question goes to all of the presentations I've seen is, how do we define affordability? Because that's really a budget question, I think, isn't it? So if you could define what affordability means.
Actually, that's probably the more difficult question, even though I'm not a propulsion person. But Jerry, you're the SSME expert there. It's double the thrust, right? Efficiency, we're still trying to figure out. Where are you, Jerry? You want to answer that one compared to shuttle since you're SSME? He says no. Okay, thank you, Jerry. But seriously, the affordability question is going to be a challenging one, and we definitely have to figure out how to do this correctly. Now, I don't know whether it's an approach, and this is something where we actually, if we can engage the community to help us with this one, is it a cost as an independent variable? Is it a design to cost? How do we go off and do this? But all we know is we've seen numerous reports that right now our architecture is unsustainable. We can't afford what we currently have. So we've got to figure out through all sorts of mechanisms how to bring the cost of launch Earth to orbit down. And that's a huge challenge that I really think the entire community needs to pull in and work on this one. So it's a vague answer, but it's a challenge that we all have to address.
Tom Markusik at SpaceX. I had a question for Todd May. I was wondering if you could tell me what the optimal mixture ratio is for this LOX-RP engine and ISP. No, I'm just kidding. I used to work for Todd. No, but seriously, I guess just my first question is just as an American, and then second is kind of a SpaceXer. The first one is why aren't we just using the F1 engine? Or, why aren't we doing an F1X? And the second thing is just a comment. I think a 10-year schedule is not very challenging. I think for small, fast-moving companies like SpaceX, we'd really like to be challenged with something like half that duration. And within the budget, I think we could do it. So, thank you.
Okay, as far as going back to the F1 question, we still have to do the system analysis to figure out, again, that sweet spot. What thrust level actually suits the most end users? We don't want to go back to developing a specialized engine for one customer, and then that one customer is burdened with the entire fixed cost of that one engine. So we've got to be careful again. The overall strategy is to develop a common engine as best as possible across all customers. And as far as the timeline, again, that was just the goal we set. That's not to say that we're not going to be able to develop an engine sooner. Part of that is, again, we need to allow time for technology to be infused into this engine development effort such that we can achieve affordability, a robust design, all the ilities. So we don't want to start right away and commit to a design without actually having good technologies infused into the overall engine design as well as the launch vehicle. So to say that it's a 10-year development time, I don't think we're committing to that. Again, through the budget process, the team is going to actually put together another baseline schedule of how long it'll take. So I can't imagine it'll take 10 years, but that's our goal. That's almost like our outset.
Oh, which one?
Oh,
I guess
sorry.
I got the mic.
Sorry,
That's
I didn't
okay.
see you back there. You got the mic.
Okay, so we're talking about a baseline LOX hydrocarbon
Right.
engine, possibility of architectures defining some other propellant types. I'm assuming, I guess this is the question for Todd maybe, the factor of robustness and, we got a question there about engine cycles. I'm assuming that, I'm sorry, I should have identified. Joe Cassidy from Aerojet. The key factor of robustness should play into this, I think, and where we design the engine cycle so that we're not stressing the engine too much. Any thoughts on that?
Did you want Todd to answer that, or you want me to?
Either one.
Go ahead.
Yeah, let's see. I would just say part of the reason for putting the RFI out was for the industry to help us think through that. I don't think we have the answer just yet, and I think it was Tom that asked about a large F1 style. If you looked at the trade space, that's a pretty broad trade space on that chart that had user 1, 2, 3, 4, and 5, and I think you'd see there's a few up there that were in the 2 million pound thrust range. So, large gas generators are in the trade space. As far as robustness, I think you do want an engine that's going to work, and it's got to work for multiple customers. And so that's obviously going to be at least one of the figures of merit. I think you hear Cris continuing to say, though, that the most important FOM coming out of the administration is something that's affordable.
Right.
And so that's going to be the driving FOM, I think, in the discussions that we're seeing, and then usable by multiple, say at least in multiple applications, if not multiple customers.
So again, just to add on that, I want to make sure that everybody knows we have not landed on an architecture or a cycle. That's what the BAA is going to actually help influence where we're going to go with this program. So the trade space is wide open, wide open.
Kim Doring from United Space Alliance. In your charts, you mentioned that you're going to finalize launch vehicle design no later than 2015. When would you expect to formally kick off the design phase?
We're actually currently defining what that will be. And again, a lot of what we're asking you all for input, the RFI and the BAA, will also influence where that milestone will land. Because again, it all depends on the architecture, but right now we're still working through what that 2015 milestone really means.
Hey, Cris, this is Mike Rudolphi. Over
Where
here.
are you, Mike?
Over here, over here.
I see you.
It's a bit of a mystery to me on this effort that we're focusing on one type propulsion, liquid or whatever you want to call it, and we're leaving out the opportunities for affordability and reliability of the solids community. Can you say a few sentences about why that's not part of the study?
Well, actually it is. If you look at the BAA, let me go back. Let me go forward. Our BAA, that's essentially the scope, and these are just excerpts of the BAA, so please, if you actually want the actual language, go to the synopsis in the BAA there. But Mike, if you see launch vehicles, it's wide open. We've got LOX hydrogen systems and LOX RP systems. We're going to look at systems that have solids as well. So this is probably the broadest study that I've seen being done, to the point where we're actually including even methane upper stages. So I don't think we're closing out and favoring a particular propulsion system in this case. Any other questions? No? Okay. Oh, is there one? Way in the back. These lights you can barely see.
Thank you. You mentioned a number of places working with commercial, and I think what you meant was commercial as an end user of engines, and that you're going to work with industry to develop those engines. Can you talk about your view of industry and how you might engage some of the newer industry players that are developing engines, maybe much smaller engines, but if you have a proactive sort of stance on bringing in those kind of players?
Well, actually, I think any procurement that we release from NASA is open to anybody, so we encourage the emerging companies as well as the traditional propulsion houses. So we're not limiting anybody from participating in this effort.